Alrighty guys, and just like pretty much any other video that we've done so far, we're going to go ahead and show some examples, or another example of an algorithm. So in this case we're doing merge sort, except this time we're going to go ahead and look at what it looks like when dealing with duplicates. So for instance, let's just go ahead and say we have an array of 3, 6, 3, 5, 7, let's put another duplicate, 7, and then 2. Okay, and so what we're going to do is pretty much how I explained in the last video. We're going to look at the length of the array and then split it in half just prior to the index. So let's count how many we have. So 1, 2, 3, 4, 5, 6, 7. So we have 7 elements, or the length is 7. And what we're going to do is we're going to divide it by 2, and that's going to give us 3.5. And what we're going to do is we're going to go ahead and round downward, so it's just going to be 3, and we're going to split right before the third index. So in this case it's 0, 1, 2, 3. So we're going to go ahead and split right here. And that's where our first split would be done. So let's go ahead and break it into two different parts. So we have the 3, the 6, the 3, and then we also have the 5, the 7, and the 2. Okay, so let's go ahead and bring it down. And again, we're going to go ahead and split. In this case, the length of this array is 3, 1, 2, and 3. And then we're going to divide it by 2, which is going to give us 1.5. And again, we're going to go ahead and round downward. So we're going to split before the first item, or the one index. Sorry about that. So 0, 1, and we're going to split right here. And then the same thing is for this. In this case, we have 1, 2, 3, 4. We have 4 elements, and then we're going to go ahead and split in 2. So we're going to split right before the index 2. So 0, 1, and 2. Split right there. And let me delete this. Okay. So now let's go ahead and rewrite our new broken down arrays. So we have the 3, which is by itself now. And then we have the 6 and the 3. And then we now have the 5 and the 7. And then we also have the 7 and the 2. Okay. So now what happens is this does not need to be broken down anymore because it is just 1, right? And that's where we said we're going to stop. So now let's go ahead and break down the 6 and the 3. This does need to be split. In this case, it has a length of 2, so 1, 2, and then 2 divided by 2 is 1. So we're going to split right before the 1 index. So 0, 1. Split here, and we're going to do that for all of them. And I'm just going to go ahead and bring down the 3, and I'll kind of explain how it ties into it later. But we're just going to go ahead and break it down. So this is 6, 3, 5, 7, 7, and 2. Okay, so in the previous video, what I said is that you basically rejoin them in the order that they were split. So for instance, we're not going to combine the 3 and the 6. Instead, what we're going to do is we're going to recombine them as the 6 and the 3. And the reason for that is because if you come back up here, the 3 was split away from the 6 and 3. And then we split the 6 and 3. So naturally in the reverse order, sorry, I don't know why that was so hard to say. In the reverse order, we're going to combine the 6 and 3 first, and then we'll combine it with the 3 later on. And then the same thing is going to apply for this. We're going to combine the 5 and the 7 and the 2, since they were joined together here. And then after we've combined all of these, or these 2 and these 2, then we'll combine them all to this. So it's basically the reverse order. I don't know why this is so hard for me to explain, but I hope you get the gist of what I'm trying to say. So let's go ahead and combine it now. So again, we compare the first item in this array with the first item in this array. and the 3 is definitely smaller than the 6. So then we'll go ahead and push the remaining items, which is just the 6 since there's nothing else to compare to. Then let's go ahead and combine the 5 and the 7. Well, the 5 is definitely smaller than the 7. And now there's nothing for 7 to compare to, so we're just going to push every other item left in this array into this new array. So 7. And then again, we're going to do the same thing with the 7 and the 2. So we have the 2, and then there's nothing else for the 7 to compare to, so 7 gets pushed here. Okay, so now what we're going to do is we're going to combine the 3 and the 6 with just the 3. And so pretty much the same thing we do here. Except now in your code, you're going to have to consider the fact of what happens when you're comparing two items that are equal to each other, because this will determine which one gets fired off. So if you're comparing, let's just say array 1, if array 1 is less than or equal to, then you're going to fire this one, or you can say if array 2 is less than or equal to, fire off here. It really depends how you want to run it in your code. But for the sake of this example, what we're going to say is the left item is going to get pushed off rather than the right item. Okay, so if they're both equal, we're going to say the array on the left is going to get pushed rather than the item on the right. So let me go ahead and kind of show to explain that. So when we're comparing the 3 and the 3, we said we're going to go ahead and push this one. So 3. And now there's nothing for this 3 to compare to. So again, we're going to push all the items left in this array down here. So we have another 3 and a 6. All right, now let's look at this one here. And again, we said that the left item is always going to take priority. That's just the way I want to do it in this example. When you have actual code, you may code it differently. It's really up to you. So let's go ahead and combine it again. So let's check the first index of each array. And so let's compare the 2 with the 5. Well, 2 is smaller, so we're going to push that first. And then we're going to compare the 7 with the 5. And in this case, it's going to be the 5, which gets pushed down. And now we're comparing the 7 with the 7. And for this example, we said that the left would always take priority, so we're going to go ahead and push the 7. And now there's nothing for this 7 to compare to, so we're just going to go ahead and push all the remaining items of this array down here. So that gives us another 7. Alrighty, and so now we're just left with these last two arrays. And let's go ahead and combine them. So let's look at the first index of this array and the first index of this array. So when we're comparing the 2 with the 3, the 2 is smaller than 3, so it's going to be pushed. And now we're going to compare the 5 and the 3. Well, the 3 is smaller than 5, so we're going to go ahead and push. And now we're comparing the 3 and the 5. Well, 3 again is smaller than 5, so we're going to push it here. And now we're comparing the 6 and the 5, or sorry, the 5 and the 6. You get what I'm saying. And so what we're going to do is we're going to go ahead and push the 5. And now we're comparing the 6 and the 7. And so 6 is smaller than 7. And lastly, there's nothing for 7 to compare to, so we're just going to push all the remaining items of the array down here. So that gives us 7 and 7. And that is how merge sort works when dealing not only with duplicates, but with an odd number of elements as well. Now, I hope that was not too bad for you guys to understand. This can be kind of tricky, so if you need to just run through it a couple times and you'll definitely get the hang of it.